Okay, so imagine this for a moment. You're standing in front of something so geometrically precise, so perfectly ordered, that your brain refuses to accept it as natural. Lines too straight, angles too exact, symmetry too clean. Places on Earth that look less like landscapes and more like architectural blueprints. These aren't myths, they're real, scientifically documented, geologically explained. And yet, when you really look at them, something feels off. Today, we're exploring 10 places on this planet that look like errors in nature's code. And by the end, you may never see random landscapes the same way again. Number 10. The Giant's Causeway, Ireland's perfect puzzle. More than 40,000 basalt columns rise from the northern coast of Ireland. Most of them are hexagonal. Many are nearly identical in size. Some reach up to 12 meters tall. They interlock like a massive stone mosaic. Geology tells us they formed around 50 million years ago when volcanic lava cooled and contracted. As the material shrank, it fractured into hexagonal shapes, the most energy-efficient way to divide a surface. That explanation is real. You can see similar patterns in dried mud. But here's the unsettling part. Mud cracks are irregular. Small-scale columns vary wildly. The Giant's Causeway maintains extraordinary uniformity over tens of thousands of columns. Why hexagons almost exclusively? Why such consistent dimensions? Physics explains the mechanism. It doesn't fully explain the perfection at this scale. Number 9. Fly Geyser, Nevada's accidental sculpture. In the Nevada desert stands something that looks extraterrestrial, a multicolored mineral formation constantly releasing steaming water. It was created accidentally in 1916 when a geothermal drilling operation failed to seal properly. Over decades, dissolved minerals precipitated, forming terraces. Thermophilic algae added intense reds and greens. There are thousands of geysers worldwide. None look like this. The mineral layering appears almost intentional, color gradients arranged like brushstrokes. Yes, chemistry explains mineral deposition, but randomness rarely produces something that resembles deliberate design. Number 8. The Wave, Arizona's liquid stone. Jurassic sandstone shaped into flowing, fluid curves. The wave looks like stone caught mid-motion. Differential erosion acted on layers with varying hardness for millions of years. Wind and water sculpted it gradually, aligning mineral grains along smooth surfaces. Erosion usually creates chaos, jagged edges, rough surfaces, fragmentation. Here, the lines flow like silk. The transitions are seamless. It feels less like erosion and more like carving. Number 7. Pamukkale, Turkey's frozen waterfalls. White terraced pools cascade down a hillside like frozen cotton. They formed when mineral-rich thermal waters released carbon dioxide into the air, causing calcium carbonate to precipitate as travertine. The chemistry requires delicate balance: temperature, mineral concentration, flow rate. Any shift disrupts formation. When modern tourism altered water flow, parts of the terraces degraded rapidly. And yet, for thousands of years, the system maintained near-perfect conditions. Without human calibration, perfection sustained over millennia. Number 6. Socotra Island, Earth's alien garden. Off the coast of Yemen lies an island that looks biologically misplaced. Umbrella-shaped dragon's blood trees, plants that appear sculpted from another planet, species found nowhere else. Socotra separated from mainland Africa millions of years ago, allowing isolated evolution. Roughly 37% of its plant species are endemic. Other islands are isolated too. Madagascar, the Galapagos. They are strange but recognizable. Socotra feels different, as if evolution experimented more aggressively here, as if slightly different rules applied. Number 5. Mount Roraima, the Cut-Edge Plateau. A massive tabletop mountain rising with near-vertical walls up to 400 meters high. Its summit is almost perfectly flat. It's a tepui, ancient sandstone dating back 2 billion years. Erosion stripped away surrounding material, leaving the plateau isolated. But the walls, they look carved. Nature rarely produces near 90-degree verticality at that scale without fracturing. And at the summit exists an isolated ecosystem, black carnivorous plants, amphibians that don't jump, species found nowhere else. It's less a mountain and more a biological time capsule. Number 4. The Rainbow Mountains, China's painted earth. Bands of red, yellow, orange, and green stretch across entire mountain ranges. Different sediment layers accumulated over millions of years. Iron oxidation produced reds. Other minerals contributed additional colors. Tectonic forces folded the layers upward. Erosion exposed them. Geology explains the palette. But in most formations, colors blend. Here, they remain sharply defined, layer after layer, as if separated by invisible borders. The clarity feels deliberate. Number 3. Marble Caves, Patagonia's Blue Cathedral. In southern Chile, marble caves glow with electric blue light. Glacial water, slightly acidic, carved smooth, swirling cavities over approximately 6,000 years. Marble is extremely hard. Erosion at that scale usually requires much longer time frames. Yet these caves exhibit fluid symmetry, curved ceilings, polished surfaces, undulating forms. The shapes are not random cavities. They resemble architecture, water as sculptor, precision as outcome. Number 2. Moeraki Boulders, New Zealand's perfect spheres. Massive stone spheres scattered along a beach, some nearly perfect circles. They formed 60 million years ago as mineral concretions grew around central cores. Gradual precipitation allowed them to expand uniformly. Their deviation from perfect roundness is often less than 1%. To maintain that precision over millions of years requires stable chemical conditions and uninterrupted growth. Even modern manufacturing struggles to achieve that consistency at large scale. Nature did it without intention, or at least without visible intention. Number 1. The Chocolate Hills, Philippines' repeating pattern. Over 1,200 nearly identical conical hills spread across roughly 50 square kilometers. They formed from marine limestone uplifted by tectonics and shaped by karst erosion. Karst landscapes usually produce irregular formations, sinkholes, jagged ridges, unpredictable cavities. Here you get repetition, hill after hill, near identical dimensions. The probability of erosion randomly producing over 1,000 similar cones in one concentrated region feels astronomically low, yet they exist. So what's really happening? Every one of these places has a geological explanation: cooling lava, mineral precipitation, tectonic uplift, erosion. Individually, the mechanisms make sense, but when you step back and look at them together, a pattern emerges. They share 3 unsettling traits. First, they required extremely specific conditions maintained for vast periods of time. A minor interruption could have destroyed the symmetry. Second, they exhibit levels of order and repetition that feel statistically rare in random natural systems. And third, they are each unique. There are no true duplicates anywhere else on Earth. Nature is usually messy, chaotic, irregular, but in these locations it flirted with perfection. Maybe they're not errors. Maybe they're reminders. Reminders that the Earth operates under rules more complex than we currently understand. When we see perfect hexagons, perfect spheres, perfect symmetry in nature, our brains hesitate. We know they are natural, but we also feel that they shouldn't be that precise. The real question isn't how they formed. Geology answers that. The deeper question is why perfection emerges here, and not everywhere. And that question remains only partially answered. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.